Welcome. Today we're going to learn about implicit differentiation and the tangent line. So we're going to concern ourselves with this particular example. And in our example, we're asked to find the equation for the tangent line to the graph at the given point. So what does our graph look like? Well, if you look at the equation we're given, x squared plus y squared equals 16, that will look like a circle when you graph it. And the point that we're given is square root of 7, 3. Okay, square root of 7 is our x value and 3 our y value. So the key here is we're looking for an equation, and the equation that we're looking for is that of a line. So if you remember from algebra, the equation of a line can be in the form y equals mx plus b. And that's what we're trying to accomplish here. We want to be able to fill in all the parts here so that we are, in the end, going to have an equation that looks like that, y equals mx plus b. Now let's look at our graph just so we have a sense for what it is we're trying to accomplish here. If you look here in item 1, that's the equation we're given. Well, that looks like, as I said, a circle, okay, with a radius of 4, and I've drawn that here. Now, we want to know the equation of the tangent line at a particular point, so I've identified in item 2 where that point is, and if you put that point on our circle, and then you draw a line that is tangent to the circle. Remember that tangent lines only touch our graph at one point, and we know what that point is. We've been given that point. So in item 3, I've drawn a line that touches our graph at that exact point. And it's the equation of that tangent line in 3 that we are trying to discover here, okay? So one thing that we know just looking at this is that if I want to know what m is, remember in the form y equals mx plus b, m represents the slope of our line. Well, the slope of our line is essentially going to be the same as the derivative of the circle at that point because they have that in common, okay? So if I calculate the derivative of the circle and I plug in the x and y values of our point, we should be able to figure out what m looks like in the equation of our tangent line. So that's the idea. We're going to begin by finding the slope, or m, of our tangent line by calculating the derivative, and in this case, our derivative is an implicit derivative. And in item 2, you can see that. In item 1, I've shown the m, just to remind you. But in item 2, we have our equation, x squared plus y squared equals 16. And to take a derivative of that, since we have two different variables here, we have to do it implicitly. So we'll do that in item 3. Derivative of x squared is 2x. Now, the derivative of y squared, since we're taking our derivative with respect to x, the way we do it is we take the derivative of y, which would be using power rule 2y, and then we have to apply kind of a chain rule idea here by multiplying it by dy dx, and that compensates for the fact that the derivative must be taken with respect to x. I do have other videos that explain this in more detail, but that's the idea. And then the derivative of 16, since it's a constant, is 0. So we've done that in item 3. Now if you move to item 4, the whole goal here is we're trying to find the derivative being dy dx. So we need to solve for dy dx. And remember that the dy dx eventually, when we plug in our x and y values, will be the m that we're looking for in item 1. Okay, so in item 4, we start to rearrange our equation in item 3 by bringing the 2x to the right side of our equation, and then it becomes negative. In item 5, we divide both sides by 2y, and we cancel the 2's, so we're left with minus x over y. But remember, we want to know not just a general derivative of the function, but we want to know specifically what the slope is at that point. So in order to do that, we plug in the points. So we replace x with square root of 7 and y with 3, and now we know that dy dx is minus square root of 7 over 3. And recall in item 6 we had said earlier that that's the same thing as our m. So m in this case is minus square root of 7 over 3. So we're well on our way to now figuring out what the equation of our tangent line is. But we have the m, but we need to find out what the rest of the line, the equation looks like. So in item 2, again, just a reminder, m is minus square root of 7 over 3. In item 3, we've replaced the m now in the equation of our tangent line. Now we have to figure out the rest. So in item 1, this is what we have so far, and we need to figure out what b is. So what we're going to do is in item 2, as a reminder, our point is positive square root of 7, 3. We are going to replace the x and y values in item 1 with this point, because recall that's the point where our line intersects the function. So in item 3 we do that, and now we've got numbers everywhere. The only letter we have is b. So in item 4 we're going to solve for b, and we do that with a little bit of algebra manipulation, and we go ahead and find that b is 16/3. In item 5, again, we now replace the b in that equation of a line that we have with 16/3, and we're pretty much there at this point. The only thing that you might want to do, sometimes people don't like having it in terms of fractions, so in item 6 we decided we would multiply everything by 3, get rid of all the 3's in the denominator that way, and in item 7 we put everything on one side of the equal sign essentially. So item 7 is another way. Both items 5 and item 7 are ways to represent the equation of our tangent line. Now just to again look at it on a graph, this is what we have just calculated. We were given a circle in item 1, point in item 2, and we wanted to know what the equation was of that line that's tangent to our graph at that point. And if you look at item 3, that is our line, that equation of our line that we just solved. And that is implicit differentiation and the tangent line. Now go practice, practice, and practice some more.